We are now going to begin talking about solving exponential inequalities. All right, so let's begin. The following two properties are useful when solving inequalities. Okay, the first one tells us that a to the x is greater than a to the y. That means x is greater than y, but only when a is between 1 and infinity, or when a is greater than 1. So you can only say that x is greater than y when the bases are greater than 1. Now, if we've got kind of exactly the same scenario here, so a to the x is greater than a to the y, if the a is between 0 and 1, meaning like a half or a quarter, anything less than 1 or greater than 0, then it actually means it's flipped around. X is going to be less than y. Now, this second scenario here is one that we don't see as often. We're often going to try to get it into a situation of this first one here, where the base is going to be greater than 1. That's normally what we're trying to do. So we can immediately, as soon as we've got it into this form, say that x is greater than y. But you need to know that this does exist, that if the base is between 0 and 1, then you have to flip the inequality sign around. Now, a safe way of solving exponential inequalities is to actually just graph it, find the point of intersection, and then decide whether it's greater than or less than it as well. So I'm going to be showing you both options here, and we can see how they both work. All right, let's deal with our first question here. So it says that we have solve 16 raised to the x is greater than 2. We want to get the bases the same. 16 is the same as 2 raised to the 4, and we've got an x there. And this is greater than 2. Now, we know that there's an invisible power here of 1. And now, because the bases, so as you can see here, my base is 2. So we're in this first scenario up here, where a is between 1 and infinity. A is greater than 1. So the base is greater than 1. So that means we can just say in this scenario, x is greater than y. So that means my powers, so it's like we're equating them, but we're using inequality now. We're saying this is greater than that. So we can say 4x is greater than 1. That means x is greater than 1 on 4. And that is going to be my answer. Now, I also want to show you another way of approaching this type of question, and it's by graphing it. And we'll use our CAS calculator here to help us out. So it says the CAS calculator can be used to help visualize the inequality. For example, for this scenario, we're going to plot the graphs of y is equal to 16x. So that's in the blue here. And we're also going to graph y is equal to 2. And then we're going to find the point of intersection. And as you can see, the point of intersection between these two lines, and let me grab a colored pen, is right here. 0.25 is 1 on 4, and of course 2. So now the question is, remember, what is the question that we're dealing with? We're asking, where is this greater than that? We're asking, where is 16x greater than 2? 16 raised to the x greater than 2. Where does that occur? Well, do you see it occurs for everything here, like not this side, but this side. So that means it's everything greater than, you would say, well, it's when x is greater than 1 on 4. It's everything on this side, not this side, this side. So when x is greater than 1 on 4, we're getting y values out that are greater than 2. So as you can see here, when I put in numbers greater than 1 on 4, I'm getting y values out greater than 2. And that's the thinking that's going on here. So if you were to think for a second, if I was to put in, I don't know, 1, I'm going to get a number greater than 2. And that's the thinking that's going on. So you can graph this either with a CAS or by hand to help think through these inequality questions as well. All right, we'll pause here and then go through some more examples.